I'm going to show you a really quick way of doing this question and then a much longer route, which is actually how I did it. Both use the fact that we've got the midpoint here, and if we connect it, we're going to split this into two rectangles. But importantly, this blue area here is going to be exactly the same as this red area. The reason for this is that we have a triangle now, and it's got the height of the rectangle and the length of the rectangle, so it's just going to be half the area of the rectangle, which is why the red one is then also going to be a half. So if we can just work out the blue area, we're sorted. And actually that's quite straightforward because we're told that each of these squares is 25. Let me just draw it here, 25. And so it's going to be 75 um, for the three squares. And then the blue area is going to be 75 divided by 2. But then we just need to multiply that by 2 to get the red area. But remember, actually, this is exactly the same as up here. So it's just 75 over 2 times 4, which just becomes 75 times 2, which is therefore 150. And that's how I can do this question. Now, I didn't actually see that method, and I went a much longer route, which I'm going to share. I wouldn't advise it, but I suppose it's good to see. But it is much more complicated. Okay, we're going to get some surds involved and some similar triangles. Because whenever I see similar triangles now, I can't seem to help but use them. But there's no need here. It's just much simpler than that. But I spotted similar triangles here. I'm going to label this the right angle. This one can be a double, and this can be shaded. And because I've got a right angle here, then this little one down here is means that is a right angle, and this will be a double one as well, because these three add to 180, and these three add to 180. This must be the same as this, and this one is going to be shaded. So just going to draw them out next to it. Actually, now we know, well, not remember, we do know some other things. We know, for example, that this length here is going to be 3 times the length of one of the squares, and the area of one square is 25, which means that the side lengths is 5 and 5. And therefore, this here is going to be 15 because it's 3 lots. What else do we know? We know that this length then is just the length of one of the squares. It's going to be 5. We could actually work out this full length here using Pythagoras' theorem. It's going to be 15 squared plus 5 squared square rooted. So you can already see why this is much more complex. And we get 225 plus 25 root 250, which you could either leave like that or you could simplify it because it's going to be root 25 times root 10 if you know how to do that with surds, which is 5 root 10. I'm just for now not going to call it 5 root 10. I'm going to call it b for the base, but that is what I mean by it. So I'm going to now label this as x here, which means that this length will be b minus x. Okay, so I'm kind of linking the sides together. And there's one other thing we see is that this length is exactly the same as this length. So the shorter side on the red triangle is the longer side, not the hypotenuse, but the other side on the green triangle. So I'll call that one y, and then this one is y here. So we can now use similar triangles to get somewhere. We can see that the ratio or the scale factor going from here to here is actually going to be 3. We're going to times by 3. We get that by doing 15 over 5, the larger one divided by the smaller one. But we can do the same for all the corresponding sides. So 15 over 5 is going to be y over x, this divided by this, and this b minus x divided by y. Now we can decide which of these we use. I'm going to use the first two to start with. So I can write down that 3 is equal to y over x, and therefore y is equal to 3x. Oh, that's really useful. And then I've also got that 3 is equal to b minus x over y. So 3y is equal to b minus x. And what that means is that b, remember, y is actually 3x, so I can write down 9x is equal to b minus x, and therefore b is equal to 10x. And that means that x is equal to b over 10, which means that y is equal to 3 times b over 10, or 3 over 10b. Okay, I told you this was complicated, and sort of unnecessarily so, because now we've actually got this bit here. Okay, this is going to be 2y. So 2y is going to be 3 over 5b. Now don't forget, b was 5 root 10. So therefore the area is going to be b times 2y, b times 3 over 5b. So it's 3 over 5 times b squared, and b squared is actually 250. That's why I didn't actually need to simplify the third. So it's going to be 250 divided by 5 times 3. We can just change it to this, which is 3 times 50, which is 150. All right, now I did say it at the start, I do not recommend this. It works. Hey, it got me there. It was so much more complicated than this, to be fair. But seeing different methods, I always say this, I know, but is good, because there's times when you might need to use this sort of application. So seeing the use of similar triangles and thirds and Pythag um, is not too bad. But yeah, this is the approach. It's better. Okay, thanks for watching. Sticking to the end.